All right, so now we're going to actually use the quadratic formula and see what it looks like. So number 3, remember that's the same number 3 as the warm-up, right? That we did earlier, where we solved it by completing the square. So the main thing with using the quadratic formula is identifying a, b, and c. So a is 7, b is 5, and c is -6. And make sure you bring the signs with them, okay? The other thing is we're not bringing x's, right? We're just bringing the coefficients. So the coefficients and their signs, all right? Okay, so keep that in mind. So now I have my formula. Let me write it over here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Good thing to remember. So what I usually do is I usually just open up parentheses wherever I have any variables, okay? And then just put everything in where it goes, okay? So a is 7. So where does a go? It goes after the 4 and on the bottom. Okay, b is 5. Where does b go? In the front 2 spots. Okay, and then c goes at the end. All right, so basically, now that we're here, I can plug this whole thing into my calculator, just the underneath there. Then we can simplify whatever we get. So I'm going to plug that whole thing into my calculator. So we get root 193. That might look familiar. Plus or minus, right? We get the -5 there. It comes down. Then on the bottom, 2 times 7 is 14, right? So we can just break that up if we want to. We can leave it like that too. But if we wanted to break it up, we could break it up like this. All right, either way works. And so that's our answer. So we have our, and remember there's 2 answers there because we have a plus or minus, but that's our answer for x. So just to remind you, if you rewind the video a little bit, you can see that same question done with completing the square, and it's a really long process, right? So with our formula, we can do it in a couple steps, right? Even though it kind of looks like doesn't look, it looks a little intimidating as far as the answer goes. It was fairly straightforward to get there. All right, and remember also, make sure you try to simplify a radical. Here we couldn't, 193. We don't have any perfect squares that go into that, so that's as far as we can go. All right, so let's check out number 4. So whenever you're completing the square, the first thing you want to do, just like when you're factoring, is you want to set one side equal to 0, right? Because our quadratic formula works when we have ax squared plus bx plus c equals 0, right? So that's how it's meant to be set up. And so for number 4, we want to get one side to be 0. So I'm going to subtract 6x and add 1 to both sides. Now you could also subtract 3x squared from both sides. That's fine too. I usually try to keep the squared coefficient positive, but that's not as big of a deal with the quadratic formula. That would be something that was important for factoring, but not as important for completing the square. For the quadratic formula. All right, so now I can see that a is 3, b is -6, and c is 1. So now I'm ready to plug it in. So x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a, right? So a is 3, so a goes after the 4 and underneath. B goes in the front 2 spots. And c goes at the very end, okay? All right, so notice when b is negative, right, we have a negative here, so that's going to turn into a positive. So if we just carry stuff down, 6 plus or minus, and then here we're squaring -6, right? So when you plug in your calculator, make sure you use those parentheses, because if you don't put the parentheses, it'll give you -36 and it'll change everything, change your results, okay? So go ahead and plug this into your calculator. So we get root 24 a 6 on the bottom. Okay, so a couple things. We can't just reduce these 6's, right, because it's a package deal. This is a binomial on top. So we have to be able to reduce something from here, right, which the 24 is underneath, so we can't reduce as it is. But 24 is something that we can simplify, the root 24. So we can make this into 6 plus or minus 24 is 4 times 6. So 4 is the biggest perfect square. So square root of 4 is 2. So it'll be 2 root 6. And then that 6 is still on the bottom. So now we can reduce everything by 2. So we divide everything by a factor of 2. And so we end up with 3 plus or minus 1 root 6 all over 3. All right, there's our answer. All right, let's try number 5. So what do we do first? That's right, we set one side equal to 0. So that's what we're going to do. Subtract 12x from both sides, add 9. So we get 4x squared minus 12x plus 9 equals 0. Okay, so now we identify A, B, and C. So remember, we're not taking the x's, just the coefficients and their signs. And so x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so the a is 4, so I'm going to put it after the 4 and underneath. B is negative 12, so I put that in the first 2 spots, and c goes at the end, and that's 9. All right, so go ahead and plug that in your calculator. So plug that in your calculator, and so we get positive 12 plus or minus, and it turns out that we get a 0 underneath, right? Square root of 0, and then 2 times 4 is 8. So the square root of 0 is just 0, right? And I forgot the plus or minus here. So what I end up with is 12 plus or minus 0. And 12 plus 0 is 12, and 12 minus 0 is 12, so we just get 12 over 8. We just get one solution. And so 12 over 8 reduces to 3 halves. And so that's our value for x. Okay, so that's a situation where we only have one rational solution. All right, so here's something you can do on the side. You can put that in your calculator and graph it. And how can you tell from the graph that that there's only one solution to this? All right, and if you guessed that it's because it only touches the x-axis once, then that's the right answer. Okay, so it's kind of one of those things where you have it perched right on the x-axis, right? So it just crosses once. All right, here's another one. So once again, this is one that we can't factor. There's no numbers we can multiply to get 5 that we can add to get 1, right? So so here's where quadratic formula is the really the only and best option here. Okay, so first of all, I'm going to identify a, b, and c. It's already set equal to 0, so that's nice. So a is going to be 1, b is also going to be positive 1, and c is going to be 5. So in the formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So a is 1, so that's going to go after the 4 and underneath. B is 1, so that's going to go in the first 2 spots, and c is 5. All right, so we get negative 1 plus or minus. If we plug this into our calculator, we would get 1 minus 20, which is negative 19, right? All over 2. Okay, so we just learned about how to simplify something like this, right? It's not real when we have a square root of a negative, but we can pop an I out, right? So we pop an I out and we get negative 1 plus or minus I root 19. 19's prime, so we can't simplify that all over 2. And that's our final answer. Okay. Remember, you could break it up if you wanted to. If you want to make it in a plus bi form, you could do that. Okay, so either way works. And I ignore this. This is just from the last problem. All right. And so last but not least, number 7 here. So you could multiply everything by LCD, which would be 6 in this case, and get rid of the fractions. But we'll just work with them in the quadratic formula. And so this would be A 1/3, B will be 1, and C will be 1/2. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. A is 1/3, so that goes after the 4, and underneath b is 1, and c is 1/2. Okay, so then we get -1 plus or minus. All right, and then you can still use your calculator to do this in fraction mode, but let's see, we'll try to do it kind of up here. So it'll be 1 squared is 1 minus, so 1 minus 4 on top over 6, right? Or I guess we can reduce the 4 and the 2 and get 2, so it'll be 2/3. So 1 minus 2/3, which is 1/3, right? So we get the square root of 1/3 all over 2/3. All right. So let me break this up to simplify. Might be a little easier. So I have -1 over 2/3 plus or minus the square root of 1/3 all over 2/3. Okay. So then in the first spot here, -1 over 2/3, that's the same as multiplying -1 by the reciprocal of 2/3, right? So I get -3/2. All right, and then on this side, I get the square root of 1/3, which I'm going to start breaking that up. Square root of 1 over root 3 times the reciprocal of 2/3. Okay, so the square root of 1 is 1. And so I get 1 times 3 on top, it's 3, and then 2 root 3 on the bottom. Now, what's wrong with this picture? We have a radical in the denominator, so we're going to multiply by root 3 on top and bottom. And so we're going to get -3/2 plus or minus. Then we'll get 3 root 3 over 2 times 3, right, which is 6. And then we can simplify one more step, divide by 3. So we get 1 root 3 over 2. So it'll be -3/2 plus or minus root 3 over 2. All right, so that's a pretty long process just because fractions, and we had to rationalize the denominator. So it might be a little bit easier in this case just to multiply everything by 6. But I just wanted to show you one with fractions just to kind of show you how that'll work out. But if you multiply everything by 6, that'll probably make life a little easier.